Recording in progress. Okay. So we should have slides up there now. Hopefully people can see this. I know we've still got people arriving as we go on, so I'll start my introductory talk, and hopefully we've got a few more people arrived by the time the session speakers begin. So welcome everyone. Thank you for coming to this OASIS session at the Ocean Best Practices Workshop. Just before I get too far into this, just want to thank lots of people who've helped to organize this session, co-leads of this session and the earlier session this morning. The overall OASIS leads also have been super helpful, and the OBPS workshop organizers have done a great job in making this easy to run. So thank you as well. And then finally, I want to thank all the speakers and all the participants. I think it's great that we've got so many people who are keen to be involved. So I'm really grateful to all of you. The schedule today, my introduction right now, and then next we'll hear from Juliet on the endorsement process, then Laura, Emmanuel, Jim, Rick, and then at the end, Q&A and D. The D stands for discussion, in case anyone doesn't understand my new acronym there. And yeah, I think as much as we can, let's try and save kind of big picture questions for the end. I think Emmanuel has to leave a little bit early, so we'll build in some time there for questions directed at him. But I think the more general questions, let's try and save everything for the end and have a big group discussion then. In case anyone is not too familiar with OASIS, and I'll just give a quick intro here. So OASIS stands for Observing Air-Sea Interaction Strategy. It is a SCORE working group. Has been that from its beginnings, I think, and then more recently became a UN Decade of Ocean Science for Sustainable Development program. There are 5 theme teams within OASIS, and I'm a co-lead of one of them, the Best Practices and Interoperability theme team. And we have online, there is a kind of terms of reference for this theme team with lots of information about what we're aiming to do and how we're planning to do that. And this workshop session is in fact part of that. The goals for this session, I'm going to keep this pretty brief for high-level overview of what we want to get out of this, really, which is that for existing working groups and the mature best practices that we're going to hear about, hopefully we can kind of give some ideas for the next steps for them. For the newer groups and variables, hopefully this will be a kind of a kickoff point for the working groups that can meet to survey and develop or update best practices and the rest of the process. And then also I kind of want to stress that for individuals as well, we want lots of people to join these working groups to contribute, but also to learn and to network. And I kind of really want to stress that we want lots of people, irrespective of career stage, location, language, and all aspects of identity. Lots of people to get involved as much as possible. And in case we have any kind of need to steer the discussion questions at the end, I think we'll have lots to talk about, but if not, a kind of overarching question I thought we could address is how OASIS fits into the kind of wider best practices community with lots of other groups, programs, organizations working on the same kind of questions. So this is the kind of XKCD comic that comes to mind when I think of this, of the situation of there being 14 competing standards. We don't want to be the people who say, that's ridiculous, let's come up with a universal standard. And then really all we're doing is adding a 15th competing standard. So I think we kind of need to identify our place in this landscape and contribute where it's useful rather than just replicating and confusing the situation. And then anyone wondering how to get involved, pretty simple. Please go to airseaobs.org get involved and sign up there. That will join you onto the OASIS email lists, and you can sign up for individual theme teams and as well as the overall email list there. And look out for future emails about how to get involved in these individual best practice working groups. So with that, I will stop my screen share and pass over to Juliet, if you're ready to.
Great, thanks, Jack. You should be able to see my screen, and should be started. Oh, there we go. And thanks everyone for being here. And I also just wanted to say a big thanks to Jack. He's put a lot of effort into putting this whole workshop together. So I'm just going to talk a little bit about Goose endorsement. What I'm going to do is play a little sound clip first. It should work. If it doesn't, and we're all sitting here in silence, someone please tell me, and I'll move on.
On the brink of a cruise on board South Africa's research ship, the SA Gallus II, I was informed by my team that we required an epibenthic dredge for the collection of biological samples. As instrument technician, it was my responsibility to identify a suitable design and ensure the timely manufacture and delivery of the equipment. With sailing date looming and having no prior experience in dredge design and deployment, I frantically searched the internet for any guides that could assist me with the task at hand. Fortunately, I stumbled across a marine sampling field manual for benthic sleds and bottom trawls, and the MESH recommended operating guidelines for trawls and dredges. These guides not only gave me a detailed breakdown of dredge dimensions and deployment protocols, but even went so far as to describe sample preservation and post-cruise data management. It definitely saved my field work, and I have since used them on numerous other cruises.
So that was, let me see if I can, that was one of my research team, a biodiversity technician, but I love that soundbite because firstly, he makes it sound so serious, and best practices like literally saved him when he was at sea, and that's how he feels. That's how we should all feel. So I like it for that. Also, you know, he was talking about a time before OBPS had reached the stage it's at now, and it kind of really makes me think, you know, he didn't have an OBPS to go to. He was frantically searching, trying to find the best practice. And the last thing that's quite nice, I mean, it's not really that relevant to OASIS, but he was using a best practice from Australia that they use a lot in their field work. And so, you know, just the fact that he's picked up this best practice from Australia and he's now using it in South Africa, it just really highlights how important, you know, internet sort of globalization can be of these best practices and how important it is to kind of share them. So really that just is to highlight, you know, the need for OBPS, but also the need for this Goose endorsement that I'm talking about today, so that really, you know, the best practices that are recommended are clear and easily accessible. So I've got this slide here. I don't think I need to talk very much to it. It's just a bit of a refresher. Since we're at the workshop, I assume we all know the OBPS. It's an IOC project approved in July 2019, and it's co-sponsored by Goose and IODE. And it supports all the different methods, handbooks, best practices, everything, even videos. And really we work with the ocean community across the value chain. And it's nice to have Jay, one of the co-chairs, here in this meeting. But I'm assuming you all know this website. So what I'm talking about today is the Goose best practices endorsement. And, you know, so if we think about really why the need for this, and basically with a bit of history, so within the Goose, key best practices have been harmonized and adopted across components of the sustained ocean observing system communities. So for example, within the observation coordination group, global ocean observing networks such as your Argo, GLOSS, GoShip, Radar, there's a number of them. And then also within expert groups and networks under the Goose Ocean Observing Panel for Climate, Biogeochemistry, or the BioEco panel, and also there's a panel on expert team on operational ocean forecast system. the ETUFs panel. And so these best practices have really been developed within each of these Goose components, and they've gone through a structured community review process, and they've been really adopted as global methods by these global observing networks. So they're recognized best practices, and they've undergone, and I'll say it again because this is really key, a rigorous process of community review. And also sort of this consensus building for the specified, either the specified application, the essential variable, ocean biodiversity or climate, or the observing platform or the sensor. And so these best practices, which have been broadly adopted by the community, they can be viewed as tested methods that are really fit for purpose and fully satisfy the definition of best practices, which I haven't got the definition here, but it's on the OBPS website. And so Goose really encouraged communities to develop these best practices across the entire life cycle of the ocean observations. So from mission through to, say, delayed mode quality control. But the problem that we found was that these best practices, maybe they weren't broadly visible, or it wasn't quite clear the kind of rigorous process they've been through. So it was really highlighted this need for Goose community adopted best practices, both within the Goose community, but also within the OBPS community. So this is a close collaboration between Goose and OBPS. So that's kind of a bit of the history as to why we have this Goose endorsement process. And then, you know, so what do you have to do to qualify? So I keep looking to the side because my slides are showing up on my other monitor. What do we have to do to have your best practices Goose endorsed? So it's really key that it's completed a rigorous community review process, but that the comments have been publicly invited and that the authors have actioned them. So it's gone out for review, gotten a whole load of reviews, but that they're actually actioned within the best practice. That after the review, the best practice is approved by the leadership of the relevant network that it falls within, or the expert team or other community leaders. And again, this was a discussion we had this morning, and I saw Emmanuel had posted in the chat. This is specific to Goose. So we're looking at the Goose network. So I'll give some examples of the process just now. That the best practice is fit for purpose, and it fully satisfies the definition of the best practices as on the OBPS. And also then that it gets recognized through one of the relevant Goose bodies, such as, sorry, best practice to turn your phone off, such as the Goose Bio Eco Panel or the OOPC or ETUFs. And then number 5, that is available and identifiable within the OBPS repository, or if it's not, the and then finally, that it is updatable at relevant timeframes. And another point that we want to incorporate is that if it is going to be published, so there's an option to publish in Frontiers in the special research topic, published in the research topic, that it is published in an open access journal so that it's available to people who maybe can't afford your other journals. So this is 2 examples here, one from the Ghost Ship, which is the one of the OCG networks. So basically, we went through some trials, and this particular paper was endorsed by the IOCCP and by the Ghost Ship network. And it was then also published in Frontiers, as well as being a standalone best practice. And this example on the right was one that had been published and then was submitted for endorsement to the Goose Bio Eco Panel. And then once they are endorsed, there's a certificate of endorsement that goes, if it's already on the OBPS, it gets linked up with it onto the OBPS. If it hasn't been uploaded, it gets uploaded as part of the. And if it's going to be published, then we highly recommend that in the acknowledgement you list that it has been Goose endorsed. So just to finish off, what we would request to the community is that continue working on creating best practices where needed, or looking at convergence where possible, sort of as Jack showed, or really just if there are identifying these best practices that could be fit for the endorsement process. And if you are going for a community review, try where possible to bring in international reviewers to really kind of highlight the global connections. To make them openly available, and then to just reach out for me for any further discussions or support. And then just to add, based on the discussions we had today, this has been set up and there's a process document for Goose endorsement, but it's very possible that if this satisfies sort of the OASIS community, then we could start with an OASIS endorsement following the same steps, and then maybe from this pick out some that then go on to get Goose endorsement. That's the endorsement process.
Well, thanks, Juliet. That's really great. I realized I forgot to do the screenshot just before, so let's try and do that now if we're okay with that before we go into Laura's talk. Sorry to break the flow, but so we've got lots of people here. If whoever is comfortable to put their camera on and I'll do a quick screenshot, that'd be great. All right, here we go. Did I get everyone there? Hang on. Okay. Sorry, let me do one more. This is like a real photo this time. We're all standing there. Okay, done. All right, thanks for your patience. So let's now move on to Laura, who's going to tell us about radiation best practices.
Great, thank you, Juliet. I was taking notes during that and look forward to kind of getting some feedback from you on what we're doing with radiation. Share my screen. And I will note that I can't see you guys when I share my screen, so if you need my attention, you should speak instead of putting something in the chat or waving your hand. No. So I'm just going to tell the story a little bit about the work we've been doing in putting together a broadband radiation best practice. These slides were put together by Daniela and I. She spoke in the earlier session. So scope, I'm just talking about broadband radiation, sort of mostly for the physical flux community, and then Emmanuel is going to talk more about ocean color. So there's other radiation measurements that I'm not focused on here. And then the scope is also about sort of all platforms. The hope is to come up with kind of what are the recommendations that can work across platforms, whether it's ships, whether it's buoys, fixed platforms, drifters, or uncrewed surface vehicles. So to kind of come up with a network of networks approach where we can use all of the different tools available to us to come up with a global picture of surface energy budget. And a little bit of the motivation, you guys all know this already. There's a lot of really exciting work happening in the ocean community, expanding measurement networks as part of OASIS and the UN Decade of Ocean Science. So it's pretty exciting to see what you all are working on and how that's moving science forward. So it's kind of a good time to think about what measurements do we really want to make as we expand these networks. And the other motivating part is this is coming out of some discussions about unifying the land and ocean measurement communities. So I come from the land. Sorry, I wasn't sure if that was for me. I think it might just be background noise, but okay. So I've been part more of the land-based community, the Baseline Surface Radiation Network, or the BSRN. Is been around since the 90s, trying to make as accurate as possible surface radiation measurements for satellite validation and model validation and looking at trends. But as you can see with this map, most of those sites are land-based because the best practices that they came up with really require stationary platforms. And so largely, I feel like the ocean and land surface radiation measurement communities have kind of evolved separately over time. So there's some efforts to try to unify our best practices amongst the two different sort of communities. Here's just kind of a little bit of overview of my understanding of the work that's been done in the last couple of years to get a feel for this sort of story, what we've been doing. So 2020 and even a little bit earlier in 2019, there were some nice discussions between Megan Cronin, Bob Weller, Christian Lancanelli, and trying to come up with kind of how do we get this conversation started, unifying the land and ocean communities. And there was an initial EGU session, I believe, in 2020 that was a bit disrupted by the pandemic. And then I think this work really started getting going with the OBPS workshop in 2020. Megan Cronin and some other folks organized the first radiation best practices workshop. And that was a great discussion. And a report came out of that kind of shaped the work going forward with some recommendations. Megan and I worked on a paper outline over the next year and started kind of putting together what are the gaps we need to fill in developing these best practices. And then we led a second workshop in 2021 at the OBPS workshop, so a year ago, where we kind of invited some other speakers to talk about areas that we hadn't covered in the first workshop. And then after that, I've sort of been furiously trying to put all this stuff together for the last year into a paper, and I've been iterating with the community, mostly the folks who were at those workshops and a few other people that we've recruited to kind of put all of that information together in a unified format. And that paper has gotten long and quite detailed and lovely. And I think we're on the third draft now that I'm just about ready to send out to the co-authors to kind of wrap things up. And then over the summer and fall, I have been trying to do my best to go to as many, make the conference circuit and talk about this work to make sure that we get feedback from kind of all the critical communities. So I spoke at the BSRN meeting in June, and then it's a couple of radiation-based meetings this summer. Tried to engage the satellite community, especially at the American Meteorological Society meeting in August. I'm hopefully going to lead a session at the Ocean Sites meeting this fall. And then I'm on the schedule to talk at AGU as well to kind of get some broad feedback and make sure that the community is aware of this work. So hopefully early in this winter, the paper will be submitted. The plan right now is to try to get it into the Frontiers once I figure out that formatting. And then work on getting endorsement and then sort of next steps for what we need to do to really solidify some sort of unknowns in best practices. That was a lot of info on that, but that's the big story. So here's a little bit more detail of some of the recommendations that came out of the first workshop. And this slide kind of highlights that connection between the land and ocean communities. I can talk about these details, or I think maybe I'll just keep moving and we can come back to details as the discussion warrants. And then just sort of to dig into that timeline a little bit more, we talked some details in the second workshop about kind of like how do we make the right measurements for the satellite community, and where are the new technologies, and which parts of those technologies and radiometer measurements should we be really focused on for best practices. And we also made a list of what are the experiments that need to be done, what is the continuing research that needs to be done for best practices that are still unknown. And I think that's kind of an exciting area as well, both to write down what is the best we know how to do right now, and what are the questions that we have for the future about, if we incorporate new technologies like UAVs to measure upwelling and albedo, how can that bring us forward to kind of the next level of measurements? So this is just actually a partial list, and then the paper will have a whole list of recommendations for kind of future work. Next steps. So I've kind of given you the story. I'm going to give you the story maybe a third time here, but I think it kind of tells what we've been working on, and hopefully gives you some thought for where you might want to go in developing the next best practices. And I'd love some feedback too on where we are and where we might go moving forward. So I told you we've been working on a community paper. It's got like 30 co-authors. We've been iterating. The draft is getting pretty close to being done. I'm hoping for sort of one more content round and then finalize the one more round of feedback on the content and then finalize the formatting and probably publish in the Frontiers in Marine Science and that sort of best practices special, whatever it's called, special collection. And then been working on getting feedback at different meetings, trying to make sure that I'm kind of covering the key stakeholders. Juliet's talk was great because we'd really love to have this best practice be endorsed by Goose and trying to understand what that takes and how that fits into the process that we've been doing and what steps we need to take there. And I mentioned this intercomparison experiments. I think a really important discussion that's come out of this is how do we, sort of put these different technologies side by side and really evaluate how well do they make these measurements in comparison to each other? How consistently can we make these measurements? And what are the sort of, we have some sort of small questions like if you're on a ship and you have the power, do you ventilate these radiometers or not? Which actually gives you a better measurement. And then, so answering some of those specific questions and then also just kind of getting that big picture knowledge that you get when you start taking measurements side by side and you say, hey, why don't they agree at this point? What's going on? So those are kind of, I think, the big directions that we need to go. And then in the maybe even more distant future, I have sort of, I imagine in my head that we could create a kind of a truly global data set where you take the best land-based measurements and this network of networks, ocean measurement approach, and you put them all into one big useful data set that a modeler can pull or a satellite evaluator can pull and kind of do some really cool science. That's just far enough in the future that I don't even know what that looks like, but I'm throwing it out there because I started to wonder. And I think this is my last slide here, but just a little bit of lessons learned, advice and from what worked and maybe what didn't work as well from our process that could be helpful for those moving forward. I think that the structure of the first OBPS workshop that Megan led was fantastic. So she had a list of sort of specific questions about people's setups and their procedures, and then asked experts in many different fields, different platforms, folks who were engineering and tech-based and folks who were more the science-based to come and say, here's what we do with our measurements, and then got the discussion going about where are the gaps, where are the challenges, how can we work together to kind of do these in a consistent way. And the notes from that workshop became a really useful report that's driven our work going forward. And the iterative writing process, I think, has been great. Sending out drafts to kind of a large group to give feedback has really, I think, helped hone the content in a useful direction. So, I might write something in there that someone else says, why would we do that? That's kind of, way out left field and way too much work. And so then that discussion happens in kind of in the writing, which has been great to continue the details there. And I think really doing the work to kind of understand what communities are going to need to give input to these best practices is important and has been something we've certainly tried to do along the way. So those are the things that I think really worked well. If I were going to do it again, I think that I would try not to do as much as I have done on my own. I think I would have started with maybe 2 to 5 people to really break the writing task down a little bit more into like some sub leads for different sections, and then maybe kind of like have a timeline, like do the sort of first workshop at OBPS and say, here's what we're, the outline we're putting together, and I'm going to have these 4 people, take on these subsections, and a year later come back with a draft together and then finish it up. I think that would have been maybe a less share the load a little bit more than having me kind of put all that together myself. So I would recommend you think a little bit about who do you want on your core team as well as your bigger community team. And I think just having a sense of maybe where to go with this best practice in the end. What is it you're trying to create? Are you trying to create a document? Are you trying to create a, right, some sense of what content should be in it from the beginning? I think will maybe streamline the process a bit more. So with that, I've talked, I'm sure, plenty, and I will turn it back to you, Jack.
Thank you very much, Laura. That was really excellent. Lots of great information in there. So next, we are going to hand over to Emmanuel, if you're still there.
I am.
Okay, good. I lost you in my picture. Yeah. So
Yeah, I'm sorry about the phone ringing in the background. It's not me. I don't know. So I'm trying to, let's see if I can find the screen for the, where is it? PowerPoint. For a reason I don't understand, I cannot load the PowerPoint. Step one. It does not seem to let me. Okay, I'll if you don't mind, I'll send you the PowerPoint.
I think you already sent it to me, so I should have that. Let me.
I might have slightly changed it. So did you get it?
Did you just email it then? Sorry.
No, I just it's on the sorry, it's on the. I just did it through the Zoom.
Okay, got you.
Sorry for those troubles. I just want to say something to the previous. There's a whole ocean color community that deals with radiative fluxes and radiation, and it's kind of unfortunate that for whatever reason, historical reason, other reason, there's not more of an interaction with the people in physical oceanography that cares about radiation. And I know you mostly care about long wave, short wave. We do PAR, UVA, UVB, and then very highly spectral resolution. But the basic problem is exactly the same. And the radiative transfer is exactly the same. And it's and we work a lot, particularly through PACE, with the atmospheric scientists. And we've produced a lot of best practice documents in the subject, including with DOIs from OBPS. So it'd be really great. And I know Jeremy Waddell was part of your group, but bringing in Robert Frouin would be extremely useful. So just go into the slide. This is what I was asked to do, to give a 10-minute overview of the kind of content that the Ocean Color community includes in best practices, the organization, kind of meeting processes that we use to determine them, and ways of communicating them. Any other lesson learned. So this is what I'll concentrate about this morning. Johannes focused more on different score groups, one of which I was part of. I have one slide about that, but mostly it's the Ocean Color. So let's move to the next slide, please, Jack. So much of what the Ocean Color community do is done within the International Ocean Color Coordinating Group, which is an international group that represent as representative of all the space agencies from all countries that have ocean color satellites, and where a lot of the sharing is done, including in the probably last 10 years, moving out of doing NASA protocols, which is how it was done for CWIPS and MODIS, and moving into protocols that are endorsed as international. And through the IOCTG, the idea was that then they will be internationally recognized and people will follow them, as opposed to if they're NASA specific protocol. This way, ESA can feel ownership and everybody else, even though even in the early ones, there was international contribution. So there's different kind of way it's done. There are the reports where there's a working group working for several years together. People suggest to the IOCCG the topic of a report. If the IOCCG endorse it, then it sponsors them to get to a meeting together, one or two, and work on that, and then publish a report on the subject. And those are also now with they get the number from OBP, the DOI. The protocol series is more topic specific. It might be measurements of absorption, of attenuation, of radiative quantities, and they're typically done by a significantly smaller group. All of those, the reports and the protocol, go out for a public vetting period, the ICCG sends a mailing for all of the community that's there saying, you know, we have this protocol, we want you to provide feedback on. After typically a period of 3 months, those comments come back, and the author include them in, and then get this protocol published. In the case of OASIS, one could think of Solus as being a good omen. The reason I'm saying it is because OASIS is a finite time project, as any score committee is, and even if it's a decade project, it will likely then diffuse, while Solus is likely to stay for much longer as the representative of your community. So you may want to use Solus just like we're using the ICCG as the home for eventual home of the output of your activities. I'll move to the next slide, please. So the protocols typically stem from invited workshop, special or around a scientific meeting. So special, I mean, we all get together in some town or some airport and discuss them around a meeting. There's an ocean science, and we get together 2 days before, where experts are assembled to discuss the state of the art of a topic. And these are international experts. And this is coordinated by NASA currently. Still, they coordinate this with coordination of leaders of the community, and a volunteer is asked to lead. So there is a leader to this. It needs to be recognized experts in the field. The little group sketches out an outline for the report, and the section are assigned to specific people. It comes together again, and as I said, it is being distributed. NASA personnel and the IOC keep tab of the progress. So ICCG meets yearly, and then ask Antonio Menino, who's the one taking care of that, you know, what's happening with the reports that you guys have initiated or have been asked to initiate, and let's go. But there's a lot of grassroots input into those, particularly associated with coming up of NASA missions. In our case, particularly now it's space. So that's a big push to get a lot of the protocols, because all the work of calibration and validation that goes with the satellite need to adhere to best practice. And so it's really key that these best practices be out there. So when people write proposal, they can say, we will follow this procedure to measure this variable. Next, please. So beyond the work I've done on protocols with the ICCG, I also co-chaired the POBPS Core Group 154. We published peer-reviewed reports on GoShip, on OceanSight, an Ocean OBPS 19 manuscript we contributed a tons to. And there's some lesson learned from that is, I mean, particularly as we heard before, all these efforts are typically done by a champion who's willing to hire the necessary people. It's a tons of work. And even if we try to share it with others, they don't necessarily are willing to get unloaded on. So it really takes somebody crazy to do it. And so you have to find the crazies in your community who are willing to do it. In my case, I'm extremely lucky that Patricia Miloslavich was there to help, even if it was just to hear me beach. She was there too. She was there from the beginning and really helped us along. There's an issue of whether you publish reports, even though they're peer-reviewed, they're not considered peer-review publication to some. And so there's I think overall people prefer going the frontiers way than going the way of a report. Even though it's endorsed by the community, to get an OBPS stamp, it does not get the same visibility as a paper going through a manuscript going out. And since the difference between them is not very large, except for the number of authors you can have on our GoShip report, I don't know, there's 70 authors. It's easier to do the papers one. But I think we got much better. When you publish a paper, you're going to get 3 reviewers. So it's a much bigger effort to go and tell the community, come and review this paper for us. You're not going to be co-authors. There'll be 3 reviewers from Frontiers, and that's going to be the product that you're going to all follow. It's much easier to give them a protocol manuscript and ask the community to give as much feedback as they can, and you know, put all of their names, anybody who gave you feedback, as a co-author, so everybody's happy, and at least it comes out as a document that everybody contributed to. So it's not yet clear which one of these 2 approaches is best. for individual people. In terms of review, I think the one of protocols seems to be a better one. You get many more people to volunteer to review it. And I'll stop there. And if anybody has question, I'm gonna run away. Unfortunately, I'm not at home. I'm in France at my father's. I was in the morning session. This is the afternoon session. I'm gonna go for dinner in a few minutes. So if you have any question, I appreciate if you can ask them now.
Emmanuel, I'd be interested in those names, but I'll contact you offline. I'll send you an email.
Sounds great.
A few folks
Yeah.
Contact.
Yeah. I think it'd be great. And there's also, I'll send you, and I sent this morning to your co-author reports that are already in the IOCCG that directly address radiometry, that are OBPS, awesome. OBPS DOI. Thank you.
Well, thanks.
Is it,
go on.
just a quick question. Is it possible to do the protocol type reviewing before going into the paper? It seems like.
You could. The question is, how would you, and again, this is just bullshit, meaning authorship, but it's how do you, people that provide you significant reviews, that how do you treat them? A reviewer to a journal, this is his job. If it's the community and somebody spent an hour, 2 hours, whatever, a day giving you comments, you have to acknowledge that in some way. And I don't, even if you can, if there's no problem giving everybody co-authorship, then there's no problem. But you know, people have problems with that, and so when we did the co-ship one, everybody who gave us a comment became a co-author, which was great.
Is there a problem with that? What's the problem with that?
70 co-author? I don't know. I mean, that's again, it depends on those that did the slug work and feel that their name is diluted. I don't know what the problem is. Community. It's not. It's the people. It's not. There's no problem in the big picture. There's zero problem. We don't care about the co-author. What we care about is that the information is out. In the small human pettiness picture, yes, it matters to people.
It is a bit. It is an issue because. You know, when you have these 70 co-authors, it's actually very difficult to find reviewers who aren't conflicted, and usually they're not conflicted because they're not in the field. So
Agreed.
You really do have to go through an internal, very rigorous internal review process. So, yeah.
It's the fun of working with humans.
Okay, well, thank you very much, Emmanuel, and both sessions today. So
thank you.
It's been a long day, I'm sure. So thank you for that. And Juliet too has done the same thing. So there's people who've been at both. I commend you. So unless there's anything else, let's move on to our next speaker. So.
Sorry, Jack, one more. So if we have questions for Laura, do we wait to the end, or do we have?
That was my intention. Yeah.
Okay.
Okay. With that. Yeah. So, Jim, over to you if you are ready.
I hope so. Let's see about getting the screen going. I think I want this one. Start it. All right, can people see that?
Yeah, we've got full screen there. So
excellent. All right, so here we go. Today I'd like to talk about a couple of things. Really, we've made such great progress in marine platforms and sensors for air-sea interaction that the time has come to start really thinking about best practices. And John and I talked. We shared notes. We shared a lot of slides. But of course, we're going to have two different takes on this, which I think is a great thing for discussion purposes, because we're just getting started. And so what I'm showing you here is 5 recent examples of our advances in platform technology. The climb mode was one. That was the first, as far as I'm concerned. year-long time series of stress and buoyancy flux measurements. With OOI, we're doing the same thing, but we're doing the processing in real time. And I should mention, I am the new PI of the Ocean Observatories Initiative, and I'm working very hard on the meteorological sensors. So we'll get that working perfectly. SPURS was the first time we added a sensor to measure latent heat flux for a year. And then the last two, the XBAR and Saildrone, are really just two examples of, well, the XBAR in particular, of as little flow distortion as humanly possible on a buoy. And Saildrone, you can't say the same for that, but the thing about Saildrone is it's long duration and it's mobile, which is a really cool thing. So I decided to give this slide second because it's my busiest slide, okay? So MO similarity theory sort of assumes stationarity, homogeneity, and really sampling within the ABL surface layer where it's about a constant flux layer. It varies by about 10% from its surface value. This is usually true over the open ocean. We have that in our favor over our terrestrial colleagues, is that the open ocean is pretty horizontally homogeneous. But you do have to take some care when you're in coastal and polar regions, say marginal ice zone, because you have a pretty large surface footprint. So you can start to incorporate other features than you might see just over the open ocean. The thing I wanted to show here was issues with sampling near the ocean surface. And we're going to be, and the reason this is an issue is because the frequency scales with the wind speed divided by the height, which means as the wind speed increases or your measurement height decreases, you are shifting the coast spectra to ever higher frequencies in hertz, not the natural frequency shown here. And so John tried to pick out a couple of points where he wanted to show that at certain sampling frequencies, at certain heights, under certain wind speeds, you're going to miss some of the flux. And I don't know if you can see my mouse, I hope you can, cursor, at higher frequencies. So, you know, it kind of depends. How much of this are you unresolving? I tried to do something a little different here. I don't know if it works better or not, but looking at this line here, this line represents a height of 1 meter. And this axis is the sampling frequency, and obviously down here is the wind speed. And what this says is that at 1 meter, if you were sampling at 20 hertz, you would start to miss the flux, which is to the right here, at about 10 meters per second. All right, you can see that at 20, if you're sampling at 20 hertz, that you do better if you're at 2 meters, better yet at 5 meters, and you really are capturing all the flux, even if you're sampling at 10 hertz at, say, 10 meters. I like this because at 10 hertz, which is what we're doing for OOI right now, we capture most of the flux here at 5 meters, which is sort of the buoy height. So there's a problem as you get close to the surface or are measuring at ever higher winds. And this is compounded by the fact that if you're using a sonic, you're also doing some path averaging. That is, sonics have roughly 10 centimeter paths. And so you cannot resolve turbulent eddies, say larger than 10 centimeters. And so if you're at 1 meter about the ocean surface, you are averaging out a lot of the fluctuations with your sonic anemometer. So all these things are issues you have to keep in mind when you're trying to measure near the ocean surface. I do want to talk just a smidge about this idea that there's a problem, and Hera and Sullivan brought this to our attention, as you get close to the surface due to the pressure stress. Now, I will just say this to this group, we're all friends. I think that's a little overblown, and I would love to see, as a best practices paper, to actually show for more realistic, not that they didn't use realistic conditions, but maybe more commonly observed conditions at commonly observed heights, what the effect of the pressure flux is in LES world. And that may be something I'll be talking to Tetsu and Peter about. And then there's always the sea spray, and that's difficulty everywhere above, say, 20 meters per second. Things are getting covered with spray. All right, so best practice, perhaps, is to measure in the ABL surface layer, but above the wave boundary layer. So that's a question we need to answer, because of course, some people are really interested in investigating the wave boundary layer. All right, so now I think I can move through a little bit quicker. Just as, excuse me, background, The nice thing about the direct covariance method on moving platforms is that you can measure the vector stress, and you can compare that with the wind vector to see when the stress and the wind are unaligned and see if that's related to things like waves. Okay. I point out that the sonic anemometer has a sonic temperature that's very close to the virtual temperature. And so therefore it is composed of both a heat flux term and a moisture flux term. And in fact, if you want to back out both the latent and sensible heat flux, you need to add an infrared hygrometer to your setup. That allows you to measure the latent heat flux, and you can then correct that term, your buoyancy flux, to get the sensible heat flux. And of course, the nice thing about measuring the latent heat flux directly is it allows you to compute the evaporation, as in P minus E, for freshening events. Instrumentation, we are going to continue to use 3-axis sonic anemometers, I think, for the near future. They're just, they're terrific instruments. The best performance, and this is, I'm not recommending any one type. This is just something that I think about, and I think John agreed that the GIL research models run and run and run and run. And when you're putting them on autonomous platforms, that's a really good characteristic. They're also quite robust. They work through rain and fairly high winds. I've used the Campbell, for example, in the ACID tower for heat fluxes. I think they have superior temperature. And then the METEC allows you to make measurements in freezing conditions. I love the figure that John put in the upper right-hand corner of icing there. And of course, we've been working for years on various corrections to these sonics, starting with, for me at least, with Henye's work to look at path averaging. Now, the direct covariance measurements, it's really flux dependent, sort of where we are with this. Stress and buoyancy, that is sonic temperature fluxes, we are the most experienced with those, probably the most success. We do now have experience with latent heat flux from buoys for a year-long deployment. It needs an open path, IRGA, infrared gas analyzer. You have to clean the optics. There's a lot of power. So you got to have a special buoy to handle all the batteries and solar panels that you need to run that. Gas fluxes are even more of a challenge. Very low signal noise in the marine environment. Probably need a closed path IRGA pump, which means a pump or a blower. The best practices now is to dry the sample volume, and they just use higher power because now you have both the sensor and a pump and a dryer. And I'm not going to go into that because that's likely to be a SOLAS effort in the near future on gas flux best practices. So I just want to say a goal of all this, accurate flux measurements are required to improve bulk formula. I think everyone in this group is probably aware of how bulk formula work. We have to first measure these direct covariance measurements along with like accurate wind speeds and air density to then solve for the drag coefficient. And so that's the same for all of these different coefficients where you use means to estimate the flux. But first you need those direct covariance measurements to improve the parameterization. So now the two things that we have to do to get to that point is correct for platform motion, and also I would say minimize the flow distortion. Here's how the platform motion works. I'm going to put a box around these guys, and then we're going to look at, so the 3-axis sonic anemometer is right there, U observation. 3-axis angular rate sensors is, it gives you the omega cross R term or the rotational velocity. The transformation matrix, which is pretty key, takes B through D. I'm going to give you a really brief tutorial on how that works, getting those Euler angles for pitch, roll, and yaw. The high pass part comes from the accelerometers. The low pass part comes from, well, I'm not going to do it yet. So if we use a strap down system and we place the IMU close to the sonic, this is our best practice, I think. That allows us to minimize the R vector, which is the distance from the IMU to the sonic sampling value. So putting it close reduces that. The reason why I like doing that is that in general, accelerometers are better than rate sensors. So using rate sensors, minimizing their use is very useful. We use accelerometers, and we're trying to get accelerometers, I missed the 2, that are in the range of plus or minus 2G. not G. Well, they don't leave the surface generally, but you never know. So that's 2G. So you have to be careful of using these nice new IMUs, though, that use plus or minus 20 G, right? It doesn't have the resolution you want. And also there's a move of foot to improve heading estimates with a GPS compass, say, on buoys. So one thing I wanted to mention, in order to get the low pass horizontal velocities, you need a current meter, even if you're sitting still or if you're moving on ships. And here's the best example I have. This is the drag coefficient. This was during climb mode. I have two panels. One is wind speeds relative to Earth. And in red is the currents that were greater than half a meter per second. In blue are the currents that were less than half a meter per second. This is relative to Earth. When I measure everything, that is when I correct for currents, the data collapses rather nicely. And so this is just a really good example of why you need to measure relative to the ocean surface. I can go back and forth here, boom, boom. It's better. We want to be relative to the ocean surface. That's a best practice. And this is how we get those Euler angles. So what we have here is a situation where the accelerations are treated as motion to the right of this cutoff frequency, and they're treated as tilts to the left of the cutoff frequency. This is known as complementary filtering. And so there's often a range in between those where because what I'm showing here is actually the degrees measured from the accelerations and degrees measured by integrating the angular rate sensors. And so where they coincide in the middle there is a good selection for the cutoff frequency. We actually set up, we rarely get to do this, and I wish we got to do more of it, but we did put a climate-like buoy upwind of the air-sea interaction tower for a couple of months. And we were able to take the RMS difference between the stress measurements at those two locations. You can see for a cutoff period, less than 5 seconds, you're in trouble. It doesn't work. But as we get out to about 12 seconds, things level off. I tend to use 15 seconds for my buoy work. And this is just a nice example showing no correction, messy spectra. It gets better as we go to higher and higher cutoff periods. And at 15 seconds, we get nice looking spectra. There are some bumps here, which I'm not going to go into today, but we continue to improve these measurements. And there's some tricks that we've developed over the years. Nonetheless, this is Core 3.5, gives very good agreement between the measurements and the parameterization on the left. That's tau versus wind speed. And it's hard to see, but the stress panel on the right shows both bulk and direct covariance. There is some work to be done, very little, but some work to be done for the buoyancy flux. It looks like the direct covariance or the bulk is overestimating the direct covariance, at least at these wind speeds. So flow distortion, in the interest of time, I'm just going to say, for the most part, we work really hard on accounting for flow distortion in the mean winds. And so there are a number of different techniques that we use. We can do it by modeling, which is over here. We can do it empirically, for example, here or here, just using the data. We can also put these things in wind tunnels, but for the most part, those are not attempting to correct for the fluxes. And the idea being that a three-dimensional flux is less influenced by flow distortion than the means. So one best practice might be minimizing the effect using low profile platforms, ships at one end and the X-bar at the other end. That is the approach that I've taken, is really I've moved away from ships as much as possible and have relied on buoy measurements and these really low profile measurements from, say, ACES and X-bar. I'm almost done. Ship-based systems, we can't give up on ship-based systems. There's too much valuable data that can be collected. But the challenge, though, is to reduce flow distortion. The first thing we do, based on all those different empirical studies, wind tunnel studies, et cetera, Fluent, is it determines the optimal placement of sensors. So we try to put it where our model results tell us to put it. There are empirical corrections for flow distortion. I've seen the Chris Farrell's group at the PSD use LiDAR measurements, which you can measure the 10-meter wind speed in front of the ship and compare it to the measurements on the ship, and you got a correction. New methodologies are coming along For example, this paper by Landwehr, and also John Prithridge has a nice paper that allows us to measure fluxes when the ships are moving at a decent speed. And so all these things are good. One last thing, this is, for me, is a little controversial, and this is where I'd love to have more of a talk with John. They are doing this decorrelation approach, which is they do the motion correction the way I would, and then just look at flat out correlation between the measurements and the wind speeds and the waves themselves, and do a decorrelation. And the reason why I'm not too upset about this approach is that it agrees very well with core 3.5 there. So the blue are their measurements and the black is my parameterization. But I rarely get big bumps like this when I've done the sort of Edson et al. 1998 plus approach. So that is a good discussion to have with our group. So the whole point of this talk is that it is important to get DC fluxes as opposed to bulk for process studies, right? So you can look at things like, the transition from land to ocean and what that footprint looks like. We're trying to make these measurements to continue to improve flux algorithms. This improves our estimates of winds as well. I mean, if it were up to me, I'd put a 3-axis sonic and a small solid state IMU on every buoy, because you get so much benefit added from that. So a list of recommendations that I've kind of gone through using sonic anemometers, using strap down systems. We're working to improve heading, measure relative to water. This one's not quite straightforward, but I suggest limiting our measurements to the surface layer, but above the wave boundary layer. That gives you the best fluxes, but maybe is not what you're after. So measurements in the wave boundary layer near the surface may require special treatment, and the need to, say, measure the pressure flux. I'd say good luck to that. Moving up and down in a hydrostatic profile with a pressure measurement can't be easy. So we correct mean winds for flow distortion. That's the means as possible. And it is important that we develop standards for quality control. And people are working on this. A lot of people working on this are in the terrestrial community. We can adopt some of their quality control in the marine community. And then I think some combination of Edson et al. Like correction, which has come a long way, believe me, with added motion wave decorrelation approach, particularly on ships, is a good thing. And I would say, last thing, share your code. I plan to. I think that is one way to make progress. And thanks.
Thank you, Jim. Yeah, I think that's a really great illustration of the range of things you've got to cover for best practices in this subject, right from instrumentation all the way to the code. So I think, thank you for that. Again, if everyone's okay, we'll save questions and just move quickly on now to Rick for the final talk of the day on carbon fluxes.
Okay, let me try to share my screen. All right. Do you see it full screen now?
Yes.
Okay, very good. All our presentations have been very different, and this one will be as well. And one thing to start out with, I am really pleased that this morning, after hearing Jim's talk, that I added, for my title, Best Practices for Air-Sea Interaction, bulk air-sea CO2 flux estimates. Just sort of a little anecdote, I was just figuring out, I met Jim about 25 years ago. And one thing that he said was at a workshop at Woods Hole, he says, you guys are not really measuring fluxes, you are measuring air-water concentration differences. So keep that in mind with Jim's correct interpretation of direct fluxes. But also what I will do in this presentation, which is going to be very general and have a bit of a historical perspective of our best practices efforts within the what I'll call the ocean carbon community, is redefine best practices a little bit as a term. And what I'll be using here is a sort of a rough definition that best practices are the cascading requirements to document the need, operating procedures, data handling, and data development. So it is not just the nitty gritty, but it also requires sort of, which I'll show later on, that sort of every step in the value chain, we have to sort of recognize this concept of best practices and consistent messaging. So our need for best practices for bulk flux measurements, and I'll be focusing on bulk flux measurements of CO2, is what I've sort of tongue-in-cheek says that air sea fluxes now really matter. And the reason is that it really matters for society, because we are talking about a climate crisis, which is basically caused by increasing atmospheric CO2 levels. And so in order to quantify these levels and the fluxes, we are basically starting to engage in the carbon community in carbon accounting, or sometimes carbon counting, which is critical for global treaties. All the global treaties that we look at are basically looking at measuring and hopefully decreasing atmospheric CO2 levels, and we will have to validate that. It's also very important to remember that in the global treaties, there's a huge focus on emissions and curtailing these emissions, but it's not just a question of sources, but it's also a question of sinks and the magnitudes of the sinks. And one of the major sinks for the global carbon cycle is the ocean sink. And in the community, we've started to talk, in the community at large, we've been talking about the forgotten ocean, that we are not paying sufficient attention to this ocean carbon sink. In addition, we are looking at means to enhance this ocean carbon sink by geoengineering techniques. And since geoengineering has sort of gotten a bad reputation, we've sort of rephrased it into marine carbon dioxide removal methods. But again, we'll have to be able to account for this carbon which is being sequestered and how much extra is being sequestered. And there are different ways of counting the carbon, but one of the good ways of doing it is, well, quantifying as it crosses the air-sea interface. So at largest, sort of at the largest level, why do we need best practices for global CO2 fluxes? And this is from sort of a societal perspective, is that we have over the last several decades made attempts to quantify the air-sea exchange and the global air-sea carbon fluxes, and done quite a good job at that. And that is shown as an example from a paper, an annual edition of the Global Carbon Budget, which is produced by, I think about 100 co-authors led by Pierre Friedrichshain, where we basically see the evolution of the ocean carbon flux over time. And the first thing that we, of course, notice is that since the atmospheric record in 1958, the start of the atmospheric record, our estimates are that the ocean carbon flux has increased roughly by threefold. But if we look at it a bit more closely, and this is using a variety of methods, and we sort of do ensemble approaches for two approaches. One is modeling, and the other one is observational-based approaches, which are shown as the orange line for the observation-based approaches and the teal line, which are the ensembles of models. We are seeing that our estimates are diverging with time. And the divergence is currently about 1 petagram, which is huge if you consider that a net flux is approximately 3 petagrams. So we as a community are sort of scratching our heads and determining why. And this could be a modeling issue, it could be a methodological issue, and it could be systematic bias in measurement. But one thing is becoming very apparent while we're trying to figure this out, is that we have to have these procedures well documented, and for the measurement we have to have best practices. To sort of illustrate, the value chain which we've developed for surface ocean carbon measurements, and the need for best practices throughout this whole hierarchy. I'm showing the value chain is a pyramid, which is Where we have observations at the bottom, which we mostly focus our best practices on, but we also have the data, which requires best practices, modeling and mapping, best practice products, and then eventually stakeholders. And I think the communication with stakeholders and the interaction with stakeholders is also going to require a best practice approach. How can we most effectively do this to share our concerns and basically get our science-based information to the people to who it really counts? Now, another way to look at sort of different parts of a best practices is to basically tear apart the bulk flux equation, which is basically that the flux of CO2 is a product of a gas transfer velocity and an air-water partial pressure difference. And in order to get the global estimates, we go through a process of taking observation both in situ, but also we are heavily reliant on remote sensing observations. Then we have to basically go through a lot of process, study and parameterizations in order to get our main products for surface water CO2 measurements and fluxes, which are what we call the PCO2 maps, our monthly maps of our estimates of global, of the partial pressure of CO2 in water, from which we can also determine ocean acidification trends, and then the flux maps. Now let's get to sort of the nitty-gritty of best practices. Our community has been doing best practices before there was such a term in many ways. And it is very much sort of a retrospective analysis because it was done fairly ad hoc, and you'll see that in the next few slides that it looks like we had everything well planned, but it was sort of an effort which sort of went with some steps forward, some steps back. But basically, we recognized early on that there is a hierarchy of best practices. That the best practices, and we've heard it in other talks as well, it is critical to be done as a team. And for the ocean carbon community, we had a group called the International Ocean Carbon Coordination Project that has been sort of a catalyst of establishing the need for documentation, then the review of procedures, the reaching of consensus, and so there has been a lot of discussion when we started working on best practices. Is this the right term? Is there a best practice? And then it really ends up being very much a consensus view, which is absolutely critical. And then we created, and then there's a really important step that we are in the ocean carbon community very, very tuned for, is that once you have them, you have to continue to update the best practices for changing needs, changing instrumentation. The first sort of effort within the ocean carbon community on best practices started in the mid-80s. And it was basically an effort which was done by a SCORE working group. And we heard earlier on how important SCORE has been in developing this concept of best practices. This was this developed into a handbook, which I sort of tongue-in-cheek call the Bible of inorganic carbon, ocean inorganic carbon measurements. And just to show the content of the first guidebook, it was basically an introduction to solution chemistry of carbon dioxide in seawater, and then a whole series of standard operating procedures for the different measurements for ocean carbon measurements. And this has morphed into a slightly different name, but the same idea, the Guide to Best Practice of Ocean CO2 Measurements. And I can assure you that anybody who does a ocean carbon measurement has that guidebook on their desk. It's been translated into 5 languages, and it is, as I say, it is extensively used. And I think for us who've been involved with it, and we've heard it earlier on, doing best practices, writing them up is really a labor of love, but it's really gratifying to see that once they're produced, vetted and advertised, they will be used, and it's really going to help the community tremendously. Now, a different sort of looking at it a little differently. I mentioned that these are a hierarchy of best practices. I'm using an example which I've been actively involved with of doing ship of opportunity measurements of CO2 measurements using automated systems on a variety of ships. And what has sort of developed and over time, and again, this was not a linear process, but we've gotten sort of a best practices bundle for a measurement. And in this case, I'll use the example of the SUP CO2, where we over 20 years ago decided as a community that we needed common instrumentation, or at least agreement on what the common instrumentation should be. And so we ended up developing a conceptual idea of what the best instrument would be to do automated CO2 measurements of surface water CO2. And we basically sketched it out and started building them, and then transitioned this to a company who is currently assembling these systems for us, and they've become sort of the gold standard of a measurement in the community. Then it was recognized that there were issues for people who were using systems on installation, so we developed an installation manual. There was a lot of questions about operations, so we have operation manuals. There are issues with data reduction and questions how to do this in a common framework. So we both had recommendations on how to do the data reduction, and also a effort to automate these data reduction to increase efficiency. And then a huge effort in the community has been to assemble all this data in an effort which we call SOCAT, or the Surface Ocean Carbon Atlas. And so here we have a cookbook on how to basically reduce the data that can then be ingested within the SOCAT database. And then the final place where we have best practices is product development. And these are basically a combination. They have ended up on web pages, they have ended up in white papers, in conference volumes, and peer-reviewed efforts. And which has been come up before is that how do we find all this? And I think this is sort of a shout out for for both this meeting and also the effort behind this best practice effort, where there's a repository of best practices. And it is really impressive how the repository, according to the website, has 1,715 documents, and also has a search engine. And so what I did is did a search for surface water CO2 and fluxes for this presentation, and lo and behold, there are 1,488 results that pop up. This is both good and bad, because it is you're not going to go to 1488 results to look for your best practices, and it probably is some issue with the Boolean search engine. But nonetheless, the first couple of pages really captures many of the best practices that we've developed within the community. Now, a bit of advertising is that one thing that we are working on in the community of surface water CO2 measurements is developing a reference program called SOCONET, the Surface Ocean CO2 Observing Network, where best practices are going to be paramount, where we basically are trying to get a network going together, which requires formalizing processes and procedures. And there it is, this issue where we want to fill the gaps, facilitate the production, establish a process for updating best practices, and advocate for the urgent need for best practices. So in summary, I hope that I've sort of got a point across, is that we can quantify our pressing environmental issues without documented clear benchmarks, baselines, and measurements of defined quality. And thank you very much for your attention.
Thank you, Rick. That was great. I think in the interest of time, if anyone has to leave right at past, then please jump in with any questions or discussion points right away. But if whoever is happy to stay for another 15 minutes, then I think we can happily do that. I'm at least happy to stay around for that long. So yeah, let's jump in with any questions. Rick, if you stop your screen share, then we can, if you're able to do that, we can get everyone on the same page. Thank you.
I thought you liked that picture of the Noah ship, Ronald Brown.
It was a very nice picture.
I think it brings back memories for many of us. But, oh, I see Sean has her hand up. So.
Hey, can you hear me?
Yes.
So yeah, this question is, well, it's kind of for the group as a whole, but it's, and I don't even know if it's so much a question as a comment, but since we're talking about best practices here in the flux area, one thing that I'd like to see some best practices developed for in terms of making the measurements and managing the measurements is some best practices for how you actually correct data for flow distortion. You know, there are a lot of techniques out there, but I'd like to see some, more distilled best practices for how you actually do those corrections. I think that would be really helpful to the community, not just the observing community, but the data managing community. And similar, and this is more of an issue, I think, on ships than it is on buoys or some of the smaller platforms. When you have multiple sensors on board the ship, best practices for selecting the best exposed sensor. That you can have, we got some research ships that are running 5 different anemometers, on them, and knowing which one is the one that's upwind or best exposed isn't always that easy when you're just looking at the data. It's the obvious one isn't always the one you think is the one. So just some thoughts. I'd just appreciate some input on that, and potentially something that could be worked on in this community.
Jim, were you about to jump in and say something there? I'm not sure, but yeah, I think I can.
Yeah. I was just going to say that there's a whole community effort right now, I think, working on buoy winds, for example. So we're all sharing the tricks of the trade, trying to get people to use that. Your second question is tricky because ships experience a lot of flow distortion, and so you get very different answers from different anemometers on the ship. What we have done in recent years is put anemometers on the bow and the stern, so that you do have an opportunity to pick which one you use. And there is quite a bit of work being done on how to take things, how to take better measurements when the ship is underway. So anyways, this is a tricky thing, and it's interesting because it comes into things like the drag coefficient, right? Because we sort of, more or less, we know that there's some problems with flow distortion in the fluxes, but for the most part, we see it in the mean. And because the mean is squared in your drag coefficient, it really can wreak havoc with your parameterization studies, right? So, which is why I think we are trying to improve the bulk formula so that that's what you rely on ship, right? And that you definitely need to worry about flow distortion if you're going to use that approach. You have to worry about flow distortion by the ship.
Related to measurements on ship, and this is somewhat of a mundane issue, but one of the things that we need for the bulk formulation is not just the surface water measurement, but also the air measurements, and knowing the wind relative to the wind direction relative to the ship is another sort of very important effort. So we can basically see if there is ship-based contamination of carbon dioxide or other trace gases. It's going to probably get even bigger if we are doing carbon monoxide and some of the other things. So I think having that information sort of readily available, and that's sort of a question in the data reduction effort or best practice, where you basically at least sort of indicate what it is, and sort of the quote unquote clean sectors would be something would be really useful for the community at large.
So I see Megan's got her hand up. Before I pass it to her, though, I wanted to make a follow-up comment about the flow distortion or the flow modeling kind of activities. One thing that would also benefit the community is some input on the best practices for doing flow modeling on a ship in terms of, what angles you want to have the flow model run from, what types of speeds, et cetera, but also what kind of output would the community benefit from having? I've been very active in the past few years working with new research vessels, and have pushed for new vessels to have flow modeling done when the vessels are being designed and masts are being designed for those vessels. But generally speaking, this stuff's expensive to run. And we're lucky if we can get a model run straight as a bow on, kind of wind, as opposed to something at an oblique angle or something. And those model results are available, from the vessel during the vessel build and design process. But I'm not really familiar with what the community could benefit from, in terms of, do they need the full 3D grid that model produces to be able to do something useful? So just a few other comments to think about.
Okay, that's good to Megan, and then Elizabeth later.
Jim, you talked about this buoy wind community, and I've been kind of in and out of some emails. I'm wondering, what is this community and how can I join it, and how can other people join it?
I could find out. I know that NASA has been working on this quite a bit. And so I happen to know Carol Ann Clayson, so I think she may have some information that about that.
Is it a formal group?
Within NASA, within some of the things that they've been doing on boundary layer winds, I think it's been disbanded since. So it may be that we don't have a community effort right now. And I have to say, I think this is a great topic for best practices, which is flow distortion and trying to figure that out. So I'll get back to you, Megan.
Okay.
I'll see if it's still ongoing. But I think it's an important thing to consider. And Rick, if you don't want to worry about flow distortion when you're sampling, just go in straight lines. I could show you a plot of where Rick went when he was doing his dual tracer measurements, and it's all over the place. So we had decent data about half the time, which is what we're used to.
All right, Elizabeth, over to you.
Yeah, I just wanted to say thank you for the really excellent presentations, and it's a little closer to my field what Laura and Jim are both doing. Jim, thanks for such a comprehensive and excellent talk. And I really felt like that was the first time I had heard all of those things summarized so well. And kind of to Laura's point, I was wondering what we want to do next in terms of translating that into a document, and whether, I know you're really busy with not only the prior jobs, but the new jobs that you have. And I'm just wondering what we can do to support you and others in translating some of the really excellent material you presented. And, addition to the other speakers too, I'm just thinking, so we saw presentations from multiple people on like different things that probably need their own document or are already in evolution. I think the direct flux community is just starting. Yeah, how can we help? I don't want to volunteer you, Jim, for like an extreme amount of work, but also you just seemed really able to summarize it so well that I would love to see, even just if we all wrote, are the chairs here going to be taking a similar route to what we did with Megan, where like the chairs sort of write down what was said and then pass it back to the speakers, or how can we translate this into some deliverable like last time?
Can I jump in? So for the direct covariance work, as Jim alluded to, within the SOLAS community, at least for the trace gases, specifically CO2 eddy covariance, we are starting to put together this sort of labor of love, as, or whatever, someone called it that, Emmanuel, or they said it was tons of work, and I can see the point, but we start to do it. And we asked Jim to participate in the initial meeting, which was last year, and nothing started after that because it takes forever, sorry. But I hope that this effort will come together with SOLAS, and we will go through the process of several workshops where we come up with multiple documents. We also want to do an exercise where we compare our codes, so where we compare our data workup. So all the different people. So I think this will, at least the direct covariance part will be undertaken, I hope, in the next year. But the rest of them, I'm not really sure what the plan is. The rest of the things presented here, like the carbon fluxes, for example.
That's great. And yeah, just, I guess, let us know, like whoever's going to be leading it, like, please let us know, or like my group is really interested in contributing. We really support this. We super appreciate all the work that Laura put into taking what started from the ocean best practices and creating such a nice document. And I would love to see that happen for this, and we're happy to contribute. And so just please let us know how we can help.
Cool.
Thanks.
Will do.
Yeah, can the OASIS best practice theme team be kind of an entryway or a clearinghouse for some of these efforts? I mean, I really want to know, how can people who are kind of doing this and care about this and really are willing to do some work, how can they get involved in these different efforts?
Well, I think this kind of idea of identifying one or two champions is just so key to it, right? That we need a few kind of people to help organize, and I think John had seemed like a really both keen and also like a good person, in that he's got a bit of experience in both the physical and the kind of gas flux side of things. So he for the direct covariance fluxes, he seems like he'd be an ideal person to do this. I'm seeing lots of heads nodding, so that's good. And I know there's going to be a lot of people who are contributing, and I think, yeah, I think that's great. I think it needs all of that. In terms of the organization, Elizabeth, yeah, I think OASIS, the best practices theme in particular, will kind of, I guess I'm seeing our role as a kind of organizational and getting the word out and helping to organize meetings and workshops and collaborative writing efforts. But given that there's a few different things going on, I think it can't be us who lead all of these individual efforts. So that's the direct covariance. I think I'm pretty optimistic that can get rolling quickly. The carbon fluxes, I think Rick kind of really well greatly explained how there are lots of different things going on. There's lots of kind of past work that's gone on, and we kind of still maybe slightly need to figure out where OASIS fits into that. But so maybe we haven't yet identified the person on that angle to take that one forward, but I think fairly soon I'm hoping the same thing will happen. So Jim, you have your hand up. I don't know if anyone else.
I was just going to say I completely agree with your with John taking the lead. I think on the gas fluxes with Byron. I mean, there's been a lot of really nice papers written recently. Dong et al. Is one that I've been looking at for best practices from, at least from ships, for example. So there's a lot of work out there. So you're not starting from scratch. It's just finding people with the time. I may, because it's now part of my job to sort of perfect our direct covariance flux system, I am sort of willing to lead that or work with someone like Elizabeth. That might be we might make a nice team. Jack, I don't know what your future looks like, but you would be great to ping off of too. So anyways, I'm prepared to help with the direct covariance, but not the gas. I kind of gave up on that, and other people have stepped up. I don't know what Byron thinks about that, but he would be a great team member as well. So.
That sounds good to me. And I think there are many members of my team who would love to work on this, and I feel like I'm also just learning a lot of this, but what I can do is be like a guinea pig of like, is this approachable to someone who just learned about this? So I feel like between me and other veteran people, we'd love to work with you, Jim, on this, because we see a lot of value in it. And also what you mentioned about the differences between the buoys and the ships. And so we, like, just our group wants to make sure that the ship measurements that we make are going to meet the standard going forward. So like, I think we have a lot invested in that. And Byron's online, but I know he's very interested in the gas stuff. So I don't know if he's online, but we're willing to help, like you said.
Sounds good to me.
Krista, your comment in the chat, am I understanding?
Yeah, I'm a little concerned that we start two efforts here. I'm starting to freak out a little bit.
Okay.
So we're already doing the gas. We're already starting it. We're already on the process. Byron is included. He was included in our first efforts. John will be included. His old advisor, Margaret Yellen, was included in our first effort that we started the process. So we hope to get all these people around the table very soon. I hope that we don't start two efforts. I really hope we don't. Please. I promise something will come soon.
And Krista, when you say we, you're talking about Solus, right?
Yes, but I mean, it's not precious to Solus. It's more that we got money already from Solus to have a workshop, and we're going to identify all the people in the community that we think are intimately involved, and we're going to ask them who they think should be involved. So we hope that it's a large community effort. So it's Solus sponsored right now, but it can also be sponsored by other people. We're talking with ISA. We're happy if we get some money through Oasis. I mean, however that would be, but everyone is welcome. But we already are starting this groundwork. So I hope that it stays as one line going forward, because I think it's hard.
Krista, for clarification, are you talking about gas?
Yes,
gas.
We
okay.
are talking about gas.
So
but
separate from.
But we hope that the physical things would go along with us, because I think it would be crazy to do one without the other.
Well, I think there's overlap in a lot of the concerns between the, EC measurements of a scalar and EC measurements of just heat and stress. And I think the important thing is just to make sure we don't duplicate too much of our effort. We can do a lot of the work on the gases with reference to the recommendations that Jim's group is going to make with respect to the stresses, because the best place to measure the gas flux is also the best place to measure the stress.
Yeah.
All right.
I think that's very well
so put. Sorry to beat a dead horse here. A student or an early career, somebody just getting in, how do they then join that group?
Working on what? I mean, so if
on this Solus direct covariance flux best practice team.
So, I mean, I guess right now we're going to initiate contact, because we have identified the people that we think are heavily working on the topic. And if those early career researchers are working in those groups where they're working on eddy covariance of trace gases, then they'll be told to us by their supervisors. I think this is the way it would go. I mean, until it gets to the point where it's broad enough that people can just sign on. But right now we are trying to control it a little bit so that we are sure that we have all the right players. And I guess if Jim does an own effort for the physical part, we just want to know what's going on, and we want to talk to each other so that we don't, like Byron said, duplicate the efforts. So, but I think it will be open to the whole community eventually. It's just right now we're trying to do it step by step so that we have some kind of control.
So I think Jim has to go. I'm conscious that we're kind of getting well beyond the time. So let's, I think, maybe start to wrap things up. Any last words? Thanks, Jim. Bye. Then please jump in now. But otherwise, thank you very much to all the speakers and everyone who's contributed to this great discussion. And yeah, I think we will have more to say about all this pretty soon. So I think this is great.
Thank you, Jack. You've really done a huge effort here in bringing together so many different groups and kind of taking stock of where we're at. And so thank you so much.
Well, thank you all. Thanks.
Mhm.
All right.
Thank you, Jack. Bye-bye.
Yep. Bye, everyone. Thank you.
Who will put together the summary? Will you do that, Jack, or?
Yeah, I can do that. I'll bring together the notes and then I'll email Jay a paragraph about the sessions.
Just while you guys are here, do you want to have a document after this? Do you want to write a paper, or what do you think?
After this, kind of after this workshop, you mean?
A little something.
Yeah, I think a little something, but I don't. Yeah, I'm not kind of envisaging a paper, but we should, you know, a newsletter item to kind of say this is what we did and this is what's coming afterwards. I think would be good if we can go into the next. If we can have, you know, half a page in the next Oasis newsletter, that might be a good.
Okay, I was just wondering what kind of level you guys were thinking.
Yeah.
Okay. Very
yeah. Okay.
Okay.
All right.
Great. Well done.
Have fun.
Thanks
Well
so
done.
much.
Yep. Bye-bye.
Okay.
Bye.
Bye.